I'm a game changer. I'm a risk taker.
Hello RoboCup Asia-Pacific. We are Team Lucky.
And this is our final team presentation for CoSpace U19. My name is Fernando Young.
And mine is Sebastião Frois.
We are both from 𝗣𝗲𝙗 School in Brazil, where we had our first contact with robot and programming, and in the name of which we participated in many competitions, such as last year's Brazilian Robot Competition and many Olympiads, like the Brazilian Mathematical Olympiad.
The main objective of the preliminary challenge is to maximize the number of points obtained by a robot in a virtual arena through collecting and depositing colored objects, while also doing other tasks, like avoiding traps and predicting the robot's location inside no-signal zones.
In order to avoid the different kinds of obstacles in the virtual world, we had to know exactly how to identify each of them, be it by their color, global coordinates, or by the ultrasonic sensors, and then discover a way to successfully make the robot go around it, which we did by creating modular dodging actions for each of them.
Navigating the map was a more complex task, as it involved creating a map that marks all deposit zones, obstacles, and object collection regions, and then devising a strategy to efficiently choose where we would go next in the shortest route possible. We did that by using the A* with post-smoothing algorithm that searches for paths for a robot very quickly and in a way that can easily be implemented with modular actions. Most notably, an action to point somewhere and another to walk in a straight line until it reaches the desired location.
We also had to create a way to make the robot patrol the regions with the most points of the same kind, which we did by marking the zones with the many objects and then create a gravitational field around it, in a way that the robot will not be able to leave a zone until it collects enough of the objects available there. We also created an exhaustion timer for the zones, such that the robot will not infinitely patrol a region, and will instead leave after patrolling it for an amount of time and not find anything.
In order to weld the ideas we talked about before in a single AI, we decided it would be best to create many types of modular actions that would be placed in two different action lists based on their priority, and then run one by one until both lists are empty, in which case the robot would search for even more actions. To do so, we used many tools that allowed for our better communication, discussion of ideas, and the sharing and compilation of our code, like Atom, Microsoft Visual Studio, and Discord.
We used C++ as the coding language for our AI, because it makes it much easier to use class and other types of variables that were vital for our strategy. After discovering and adapting ourselves to the programming language, we decided that the best possible code structure for our AI will be to do a preliminary set of processes each turn, in the following order. The robot will first check for swamps, non-signal zones, penalty, and super objects. Then it checks for the normal action it has to do, following by checking for any emergency actions, only then selecting the action with highest priority to execute.
In the end, our code was messy and buggy, so we had to spend a lot of time correcting our many mistakes, which gave us the opportunity to better organize and review our AI, changing many things that drastically improved our performance. To do that, we separated bugs into 4 different groups. Code structure errors, like missing semicolons, that would be fixed with the help of Atom's linter. Mathematical errors, fixed by rewriting and checking equations. Logic structure errors, that were fixed by analyzing our code part by part and seeing where things went wrong. And finally, platform errors, which were the most annoying to deal with, as they involved the way CoSpace processes information and variables, and we couldn't change that, so we had to spend a lot of time trying to work around them.
To give you one of the most notable bugs that appeared, we set the 𝗃 pathfinder algorithm that we tried to implement before a star, as it also creates efficient path, and in a way that was very compatible with our coding logic. However, we couldn't do it, mostly because the algorithm would frequently spiral out absurd paths that would lead to a huge waste of time for the robot. So eventually, we just gave up and decided to implement the A-star algorithm that was simpler and more precise.
Another thing we couldn't fix were our equations for predicting the robot's position inside no-signal zones, because the variables given by the game are too imprecise and the equations had many corner cases that were difficult to deal with.
Even with those errors, however, our code was able to perform very well in the end, achieving some very high scores, like 2500 in a single match, and outperformed the makeshift code we first made using the full AI coding platform. So we are both very satisfied with it. The competition also gave us the opportunity to learn many new things, like pathfinder algorithms, how to better use C++ and other tools, and that teamwork is very important to develop better ideas, as it gave us the chance to discuss what we have in mind and how to improve our strategies.
Lastly, we have some handy tips and tricks for new CoSpace programmers. It is much easier to use C++ to code the AI than it is to use either C or the default programming platform, as it gives you a lot more versatility to create whichever ideas you have to code. Try also using Atom and Visual Studio to develop your code. They are both amazing coding platforms and have different utilities that make them perfect to share and compile your code flawlessly. That's it for today. Thank you for watching our presentation.